Hello and welcome to the first TypeScript video of the Blind 75. So the first problem we're going to be doing is toSum, and I would imagine most people can do this, but I will go over this briefly. You have an array and you're looking for a target, so like in this example, you are looking for two numbers that add up to some number, and I think your numbers have to be, well, actually they can be negative as well, but essentially you're looking for two numbers that can add up to some number and you need to return their indices. So like in this example, it would be these two numbers. And in the second example, it would be these second two numbers. And then in the third example, it would be the first and the last number. And there is always a valid solution, so you don't have to worry about like not having a valid solution. But essentially, the way you could do this is you could do an n-squared approach, where you could just start with every number. So like, let's say you start here, you would check every number past this number to make sure, you know, do these numbers add up to my target? So like you would say, like, do these add up to 9? Do these add up to 9? Do these add up to 9? And then do these, and so on. These. Okay. Now, the more optimized method is you want to actually store the numbers that you currently have with an index. And then, so let me show you what that would look like. So like for number 2, we would look for the complement of that number. The complement meaning target minus that number. So minus number. So for example, for 2, you would say like, is 9 minus 2 in our whatever we're storing? Let's just call that cache. And right now our cache is going to be an empty object. So is 9 minus 2 in our cache? No, it's not. So we're going to store. So if it's not, we do need to store the object. So we're going to store, the key is going to be the value, and then the key is going to be the number, and then the value is going to be the index. So then for 7, we're going to say, okay, is 9 minus 7 in the cache? And yes, it is. It's right here, and its index is this. And then we will just simply return an array of the index in the cache and the current index we're at. Same for 324, right? If we have 324, you would say, okay, well, here's our cache. You'd say, okay, and we're looking for 6, so you'd say, is 6 minus 3 in our cache? No, it's not, because our cache is empty. So let's just store 3 with index 0. Then we would go over here and we would say, okay, 6 minus 2 in our cache. No, it's not. 4 is not in our cache. Then we would store 2 at index 1. And then for 4, we would say, is 6 minus 4 in our cache? We would store 2. Okay, sorry. 2 is in our cache. So then we would just get that index, and then we would return the index of whatever that was plus the current index. All right, so pretty straightforward problem. Not too much to do there. So we're going to more focus on the TypeScript part of this. So what we're actually going to do here is we're just going to take this toSum. We roughly know what we need to do, so we don't really need to worry about it too much. But I will come back to it. But essentially what we're going to do now is, so remember in our first video, and if you didn't watch it, I would definitely encourage you to watch this because it's going to be kind of hard to do this without this. We set up a TypeScript config, and we set up a package JSON package lock, and then we set up this TypeScript file where we're actually going to be writing our code for the problems. And the reason we want to do this is because if you write this in LeetCode, LeetCode will let you do stuff that, you know, a normal TypeScript program that you're going to be actually working on at your job probably shouldn't be allowed. And now let's see like what errors we get. So what errors do we get? So nums is declared and its value is never read. That's good. Target, same thing. And this number, it's saying function whose declared type is undefined, void, or any must return a variable, is neither. So we're not returning anything and we're not using these. So that makes a lot of sense. And we'll handle that as we go. Okay, let's just make our stuff and then we'll see what happens from there. So first of all, let's make our object. So what we want to do is we want to make an object, and we want the fields of the object for this problem. The key needs to be a number and the value needs to be a number. At least those are the types that we're expecting, right? Because we're taking a value and then an index. So how do we do that for the types? So you could actually do this. You could write a record, and you can write number. And that will give you the types of, so this is the key type and this is the value type. And so that will essentially tell you, okay, the key is going to be a number and the value is going to be a number. And let's just make that this for now. And let's see if that works. Let's just try to break it. So what if we do like object at number 5 equals null? Type null is not assignable to type number. Yeah, so we wanted a number here and we gave it null. So that worked. What if we give it a string? That also works. So this is expecting the way we want. Now let's try for the key. Let's try for the key maybe where we write some stuff here. Implicit element implicitly has any type, but index expression is not type number, right? So the index is not type number. So you can see like we can't write a non-number into this object. So we have to have a number here and a number here, and then it works, which is what we want. So that's perfect. Okay, so now let's actually go into our for loop. So let's just say for let I equals 0, I is less than nums.length, I plus plus. Okay. So now what we need to do is we need to actually get that, like we need to get that value and we need to check, is it in the, or sorry, we need to get the complement of the value, right? So we're going to say maybe like let complement equals, and so it's going to be target minus nums I. And we also want type of complement to be number, right? Okay, so let's see what issues we're getting. So we're saying object is possibly undefined. So they're saying nums I could be undefined here, and then you're like subtracting an undefined number. Well, that's no good, right? So we want to check for that as well. So how do we do that? Well, we could just say like const something call like cur or something equals nums I, and this part, I think we can give it two types, right? So it can either be a number or it can be undefined. I believe this is how you do it. Yeah. So we're just going to say, let's just make a current. It can either be a number or undefined. It's going to be nums I, and then we're actually going to check if it's undefined. So we can say like if cur, or I guess it would, I think you could do something like this actually, because undefined should be falsy. We could just say continue. Yeah. So we could do this. And so now essentially we're saying we're getting the value. We're saying, okay, if it's undefined, let's just not even get to this part. And now we're going to replace this with cur. And now we got rid of that error. So you could see like there's a ton of errors you're getting in TypeScript depending on how strict you're making, but then you are benefiting from that down the road. Now, if you did want to get rid of all this undefined stuff, if you're like, look, like this can't be undefined, I don't care, like leave me alone. What you could do is, remember we checked this. So if you actually uncheck this and we go back, and we get rid of this, you can see like there is no error here because we're saying like, yeah, I know it can be undefined, I don't care, leave me alone. So we're actually gonna go back though, and we're gonna keep that code, but that's up to you. If you think it's too much of a pain, you can get rid of that. So it's gonna be this undefined variable. So we're gonna set that equal to true again. So we don't want, we are gonna say like, just check for undefined and let me know anything that can be undefined. Okay, let's get rid of this. So now what error do we have? So complement is never read, obviously, because we haven't used it yet. Okay. Now what we need to do next is we need to actually check if our object has this complement in it. So we can say like if, and the new way to do it in JavaScript that's like newer is you write object dot has own. I think it's like this. I'll double check this. Yeah. And so what this does is it'll check if the key is in the object and not in its function and not in its prototype. So obviously, like for this, it's not going to be an issue, but for other things, like your key might be in the prototype, and you actually want to just check the object. And so the way this works is you give it the object, so that would be object, and then you give it the key here. So if it does have it, then what do we want to do? We just want to return something. But look, we have another problem. So let's see. Property has own does not exist on object and constructor. Do you need to change your target library? Try changing the lib compiler option to ES22 or later. So this has own is pretty new. And so if we actually look, our target is ES 2016. So that is the 2016 version of JavaScript. So let's actually use the updated one. Let's just use 22. We'll see if we have an error with that down the road. But for now, let's use 22. And you can see that went away. Now you could, if you don't want to use has own, you could use has own property, which is essentially has own is like trying to replace has own property. Okay, so if this is true, then we want to actually return an array here. So let's see what happens here. So we want to return an array ideally of, and now, I mean, we probably don't have to check the type of this value because we already checked that in here, right? We made sure everything that goes into this object is a number. It can't take like undefined or anything. So we could just say, and let's see if we get an error here. So object complement was the first index, and then the second index was I. And let's see what issues we get here. Type undefined is not assignable. Okay, so it's giving you that undefined again, right? So you have to check for undefined again. So maybe we could do that as well. So maybe we could say like if object dot complement does not equal undefined or something, right? That would make some sense. So let's see. Type undefined is not assignable to type number. Yeah, so it's still giving you the same error. So I think we might have to save it again, like we did last time, right? So we might have to like save it in a variable as well. Okay, so let's do that. So let's just say const output or something, or res equals object complement. So we could do that, and then we can just say like, let's just const declarations can only be declared in a block. Okay, so let's make this in a block. Okay, and now for a result, we're going to want to make that type undefined, or maybe like number and undefined. And then we could say if result is not even undefined, let's just use result. Okay, so we got rid of that error. So that's how you would get rid of all these undefined errors. If you do think it's tedious, which probably is for this problem, you can definitely get rid of that in the compiler if you wanted to. So this is like a little bit of overkill maybe. But either way, let's keep going. So now we have like okay logic here. So now the last part, remember, if the complement isn't in the cache, we need to actually save it into the cache. And so let's do that here. Yeah, so I is guaranteed to be a number, obviously, but we could also, if we really want it to be super, oh, actually it is giving us an error. Function lacks return ending statement, and return type does not include undefined. So we might need to do something here, right? So let's just try to actually make an object here. So we could say like constant output equals this. And let's just say we also expect that type to be number and number. And let's see if we have a problem here. It looks like we don't. And if we return output. Okay, so that part is okay. So now what we need to do is we need to actually, so we're going to go back to this later, but let's actually do the last part of this. So the last part of this, we actually need to add this to the object. So we're going to say object, and then this is going to be I. No, it's going to be complement. No. It's going to be, so we need to save the number that we're currently at, right? Yeah. So it's going to be object nums I equals I. So let's see if we have another issue. So yes, we do. Nums I cannot be used as index type. So we need to also save that. Yeah, so we have a problem there again, which is definitely getting annoying for sure. But luckily we have this cur, so we can use cur here. Okay, object cur equals I. There we go. Okay, but we're still function lacks ending return statement, and return type does not include undefined. So essentially what this is saying is we are guaranteed to have a solution here, but our complaint now is that TypeScript is saying there is it doesn't know that we always have a solution. So there is a return route here where, like, let's say you go through this loop. Now we don't have a return statement, but we're expecting an array. So maybe we can just return an empty array or something. Does that fix it? Yes, it does. And I'm curious actually if we can actually just return this directly or not. So this is, we're going to be definitely doing a lot more like guess and check type of situations, but let's see what happens. So if res does not equal undefined, let's do this. Okay, so we actually didn't need that. So there we go. So so there we go. I am curious a little bit on like why it doesn't think I can be undefined, but I guess maybe it just knows that in a loop it can't be undefined. I'm not exactly sure how that is. But essentially, yeah, so if you wanted to save a ton of your code, maybe I'll probably do this for the next problem just because it is a little bit tedious and like these small problems checking all these undefines. So actually, I think I will do that for now. but maybe I'll change it back later. But it definitely does seem to be tedious. And let's get rid of some of these undefined. So now we can say like, get rid of this code, right? And now we can have nums I. Oh no, it is actually giving you a problem still. I think it's because I didn't save the TypeScript file. There we go. Okay. So now we can also get rid of some of these. So we're just going to say like, look, we know our stuff can't be undefined. We're good. We trust it. Okay, so now we can say object, and then this is going to be complement. Okay, there we go. And then this is going to be object nums I now. So essentially we simplified our code a little bit, not to have so much of it. Okay, and so, okay, I think we screwed up something here. So let's look through this. I think this is extra. Okay, there we go. So now essentially we're not checking for undefined. They could be, and that's like up to you. Okay, so now let's go through this one more time. So I know this was kind of long for just a two-sum, and hopefully it'll get a little bit faster. But you can see this is definitely tedious. Like the more strict you get, the more tedious it gets. But the whole point of this is like once you have a big program, you're doing all your debugging here, and then you're not debugging, in a huge program. So that's like the pros and cons of TypeScript. So for our record, we are making sure the key and the value are a number. And then we are also saying the complement has to be a number. Maybe you don't have to include this. Like at a certain point, you could be like, look, I know my array has numbers, so like, why would I check for a number? Up to you. And then we are checking if it's in the cache. And then if it's in the cache, we're just returning it. And then finally, we are adding it to the cache. Okay, so let's try this in the LeetCode problem. But yeah, essentially for the LeetCode problem, if you were to do... Yeah, so I did also notice this. So I think the LeetCode, because I can't edit the LeetCode compiler settings, I think the LeetCode compiler settings are kind of old. So it's using like ES 2016 or something. So it's giving you this red. It'll still work. You could use an other field. So you could say like this if you wanted to. So this is like object has own property. I believe this is like this format for the old one. So that would work, and it's pretty similar. But also the problem is in LeetCode, I'll show you here. So remember we made this object that takes numbers, so you can actually do things like this and it's not going to give you a problem, which is like a little bit weird. Actually it is. Okay, let's try the other one. Yeah, so it does let you do this, even though, we probably don't want this because we're expecting a number. Also, I think if let's try undefined or something. And that also works, which is something we don't want. So like this one isn't as strict as a custom compiler you can make. So it's just kind of up to you what you want to do. And I thought that to learn TypeScript, you probably wanted to work on something strict. Otherwise, kind of like, what's the point, right? Like we're not doing this just to solve LeetCodes. We're doing this to learn TypeScript. Okay, so let's see how this goes. Okay. So that did work. But yeah, I think in the future, we're definitely going to be, as we're going to be getting into more problems, we're definitely going to be speeding up. But there was a lot to cover here. Probably going to get rid of the undefined thing in the future just because it is a little bit tedious for smaller programs. Maybe I will add it if I want to check for some of that in the future, but for now, we're going to get rid of it. So yeah, it's going to be all for this video, though. And if you liked it, then please like it. And please subscribe to the channel. And I'll be releasing more of the Blind 75 in TypeScript in the future. So thanks for watching, and see you in the next one.